I'm Andrew Kim from KGSEA Math Circle. Today I'll be giving a lecture on neural networks. So you probably clicked on this video to learn more.
할 때 근데 이게 되게 중요해. 왜냐면 이제 영상이 나오면 되게 아마추어스럽게 보이잖아. 그러니까 할 때 훨씬 좀 가져야 될 거. 너 저기 스크립트 써놓은 거. 그거 보라고 이거. 책 한 번 하고.
일단 오케이. 다시 시작할게. Hello, I'm Andrew Kim from KGSEA Math Circle, and today I'll be giving a lecture on neural networks. So you probably clicked on this video to learn more about neural networks and recent developments in deep learning. And they are certainly fascinating, so the goal of this lecture will be to give a brief introduction on neural networks. On the side here, we have three essential questions that I want to go over today. So they are, what are neural networks, how do they learn, and what are some practical applications? Before we actually get to look at a neural network, I just want to compare how computers and humans function. So computers rely on deductive reasoning, and that's the main reasoning behind algorithms. We apply certain rules and computers use them to solve certain problems. On the other hand, humans use inductive reasoning. They're given inputs and learn through trial and error. That's why humans are considered dynamic. As we're given more inputs, we learn, whereas computers are static as they rely on a certain set of rules. So computers are really good when the rules are very clear, whereas humans are good at using noise data that's unclear and where the rules are not directly written. So this makes computers very difficult at being used for problems such as image recognition or other tasks you consider intelligent. So to clarify all of this, I just wanted to give an example. So let's say humans were to learn about linear equations and solving linear equations. So computers would probably use a standard mathematical method such as Gaussian elimination, whereas humans would first learn about linear equations, what they might represent, and through a process of trial and error, we'll eventually get to learn more about linear equations in general and how to solve them. So the problem with computers is that if we throw like quadratic or cubic, it would kind of throw them off. They wouldn't really know how to solve it. Whereas humans, we learn, oh, we could apply certain rules to these and be able to solve them. That's why we're dynamic. So the solution is to mimic the human brain, at least the structure of it. So here is a very simple diagram of a neuron. So on the right side, we have the dendrite. So the dendrite basically, to sum it up very simply, receives chemical signals, and based on the strength, so whether it's excitatory or inhibitory, it releases action potential. And then to the axon, it can release more signals to other surrounding neurons. The main takeaways from this are neurons are very small and simple. They basically receive a single input and give an output depending on the strength of the signal, but there's a lot of it. There's nearly 10 to the 11th power neurons and about 10 to the 14th synapses in our brain. And our brain is able to learn by adjusting how individual neurons react to connections and the strength of the signal. So here is the neural network structure. So we can divide into three layers: input layer, hidden layer, and output layer. And I just want to focus some time on each one. So the first layer is input layer. This is where you're given data to your model. So it all depends on what you want to train your model for. So for example, let's say we want our model to recognize handwritten digits. Then we would probably include the color of each pixel into our neural network. Or what if we wanted our model to predict whether to buy a used car? We would include variables like the engine model, the car model, the date it was released, number of defects, certain things. So the input layer depends mostly on the problem you're trying to solve it. You can also apply different strategies of denoising the data, so there's standardization. You can also denoise it using Hart-Waflet transformations or Fourier transformations, but They're really complex and probably deserve a lecture on their own, so I won't go into much detail about them. So hidden layers are where the really exciting things happen. So the role of the hidden layers is to recognize patterns and general trends in our data that will help us lead to our output. So going back to our handwriting example, our model is trying to learn to recognize different handwritten digits. So if it sees 2 circles, it might correlate that with an 8. If it was a horizontal and a vertical line, it might correlate that with a 7. So the goal is just to recognize general trends that will help lead to the output. And finally, the output layer is, well, the output layer. Depending on the results given from your hidden layer, we will get to certain output. And these are all probabilistic. So the model gives basically a probability of a certain output being correct. So for example, like a 70% chance it's 7, 20% chance it's 8, etc. Something like that. That will be an example output. So you probably often heard of the phrase training a model. So to do that, we first actually have to look at the very basic structure of a neuron. So in a neural network, we can basically divide it into layers. So what a neuron does, it takes each input from the previous layer and assigns them weights. And afterwards, we sum them up and we apply something called an activation function. So common examples of an activation function might be sigmoid function or the tanh function. We won't go into much detail, but basically the goal of the activation function is to account for nonlinearity. It's really just a fancy way of saying that not all the patterns we observe are linear. And the goal of the activation function is for our model to be able to observe more complex patterns that are not available with just linear weights. So how do we actually get to the weights? Well, we use a method called gradient descent. So just imagine that you're on this hill and your goal would be to get to the lowest point. That's basically what gradient descent is. So on the y side, we have the cost, or basically how much error our model is producing. And usually when we train a model, we start from just initializing with random weights for every single connection between neurons. So starting from that random location, we basically run our model through, we test it, see how much error we produce, and then from that, we try to get the gradient, which is, you can think of it as a slope. And using these small steps, we basically get down to the valley, the minimum amount of cost compared to our weights. And through that learning process, we gradually update our weights to be more accurate. And because it's iterative and because we depend on the previous weights, we can learn relatively quickly. So depending on the problem you want to solve, there's also different variations to neural networks. So the one we discussed today was the very most fundamental version of a neural network. There's an input layer with hidden layers and an output layer. But actually, we can get much more complicated. So for example, on the top left, you see a RNN. So those are basically used for time series data and for something that you need to recur or you need something to repeat. On the bottom, we have an LSTM, which is actually a form of RNN. And on the right, we actually have a convolutional neural network. So depending on these variations, we can make the original neural network much more stronger and be able to achieve certain checks. So for example, the convolutional neural network I just showed you was actually a very popular model called YOLO, you only look once. And it has very many applications in things such as autonomous driving, where you have to detect objects. LSTMs and RNNs are also particularly used for stock prediction. It basically trains on the previous inputs or the previous stock closing prices to output the next one. So these are just some of the few applications we have for neural networks. I really hope that you continue learning about deep learning. This is really just the tip of the iceberg. There's many more ways you can go down the road. Thank you for listening and have a nice day.